All right, so I was trying to get things to cover, and I looked in George's book, and these are his axioms, things that he says you have to assume are true. And I wanted to make sure my proof systems is good, so I went and checked, can I prove all his axioms? All right, so here's an axiom that he has, and so let's try to prove it. All right, and what is it? It says if we, right, we have here is the reason I call it the distributive law. He didn't call it that. I call it because here we have kind of a Forall outside of the brackets, and we're bringing the brackets inside, right? So it feels distributive to me. All right, so we want to prove it's true, and so let's first build up some intuition about whether we think it's true or not. All right, so we can think, what does this mean, right? Here we're saying for every x, we have this statement. Yeah, so if we know that's true, one thing that we know is true is that if x is 0, we have it, right? So let's start with what does it mean when x is 0? Well, it means if we assume alpha is true for 0, remember we're given which objects alpha is true for, and we're told which objects beta is true for, right? And what do we know? That's what our universe gives us, right? And we don't, those are arbitrary, right? So we say, suppose alpha happens to be true for 0, then beta will be true for 0, right? That's what it means. You all know that. So what does this mean? Well, it means for all x, that's the case, right? If alpha is true for 1, then beta is true for 1, right? If it's true for 2, and it's true, beta is true for 2, right? We get all of these as separate statements, right? Everybody see that's what we're given. We're given that for each object, if it's true for that object, then the beta is true for that object. All right. So the other day, maybe I should put this in the slides because I kind of like it. All right. Here, what's alpha? Alpha says person X wants to play a game, right? And beta is person X does play a game. All right. So what does this say? It says for every person at the party, if they want to play a game, then they play a game, right? We have this individual freedom, right? People in America would be happy with this. Everybody gets to decide whether they play a game or not, right? All right, so now, what else does this give us? Does this give us that if alpha is true for 0, then it's true for 1? Right? Does this say that if 0 wants to play a game, then 1 has to play a game? No, it doesn't say that. In fact, in America, that would be horrific if we impose on somebody else that they, right? Just because, one person wants to be gay doesn't mean another person has to be gay. Everybody can do exactly what they want, right? All right, so that doesn't happen. Here, so what does this statement say? It says, well, our oracle, right? We play the oracle game. The left-hand side, what does it say? The left-hand says, everybody want to play the game, right? Suppose everybody wants to play, then what do we know? We know that everybody gets to play, right? So this is more the difference between the East and the West, right? In the East, it's more collective, right? If everybody decides that they want to play, then everybody gets to play, right? Does that make sense? Right? Suppose you only know that suppose only 0 wants to play. Then what do we get? Do we know that does 0 get to play? Suppose I told you this statement here, right? And I told you that alpha is true for 0. What does that give us? Does it give us anything? Come on, guys. We got one little nod. How do you get that, though? This says, if they're all true, then you get all of them, right? But if only one of them's true, do we have the left-hand side? No. So do we get the right-hand side? No, right? And you can imagine you're in the East somewhere, and you say, hey, I want to play a game. And people says no, right? You say, hey, I want to be gay. No, you can't. Why? Well, because everybody doesn't want to, so you can't, right? All right, so now we want to prove this. How do we prove this? Well, the oracle's assuring us that we're in America, that if any individual wants to play, they get to play, right? And so now, so that's what we did here right by the game, right? We assumed this, and we want to prove that, right? How do we prove that? Well, we assume this, and we try to prove this, right? Does that make sense? All right, so that's why we assume this, because we got it from there. That was our first oracle. And then our second oracle, we're assuming this, right? Those are our two oracles. And what we want to prove is prove this. All right? How do I prove for all x? Exactly, right? How do I prove, right? Well, here I'm not doing it. I'm just saying individually we get them all, right? But really, I guess this slide was made earlier in my life, right? So here we're saying, yeah, if we get, the adversary is going to give us, say, hey, do it for prove beta 2. How do we get beta 2? Well, we know that if alpha is true, we get beta 2. And we know that alpha 2 is true, right? So we get beta 2. Right, everybody good? And the other direction, right? Is the other direction true? Right? What about the reverse? So the reverse says, right? If everybody wants to play, then everybody gets to play, right? Right. Now, how do we prove this side? We say we want to prove it for all x. So you give me an arbitrary x. Say 0. What do I want to prove? I want to prove that if alpha is true for 0, then beta is true for 0, right? So right? Right? It's just not the case, right? So we need to build a model. So now we believe it's false, right? So to believe it's false, we get a model in which it's false, right? So we work backwards to build a model, right? So how do we work backwards? Well, we want the whole thing to be false, right? That's our goal, is find a model where the whole thing is false. So then there's this implies here, right? How do we get that implies to be false? Right? We get that to be true and that to be false, right? How do we get that to be false? Well, we get one little example here to be false, right? If we get this example to be false, then this for all is false, right? How do we get this example to be false? Well, we make that true and we make that false, right? Everybody buy that? All right, so then we come over, how do we make right? So that's just translating what we had already. How do we make this thing true? Right, to make this true. Well, how do we make this implies true? Right? You could do it. There are a couple ways of making it true, right? We could make this true and we can make this true, right? Can we make this guy true? No, this guy's false, right? So if this guy's false, how do we make this whole thing true? Right? We have to make this false. Then we have to make this false, right? So, hey, so we have that is false, right? So to make that true, we have to make this false. How do we make this false? We make that guy false, right? Everybody see that? So here's the situation where, right, this is true, but, right, 0 wants to play, but 0 can't play. Why can 0 not play? Because 1 doesn't want to play. Right? Does that make sense? Right? Right. So, right. So now I guess we'd say, well, we worked that out. How do we write it up? Right? Right. Well, we have to specify the model. So I have to tell you that my objects are 0 through 4. I have to tell you what my alpha and beta. Well, I don't have to tell you all of it. I tell you just as much of it as I need. Right? So I tell you these values. Right? And then I crank in. Well, this, because of this is false, right? Because of this is false. And hence this is true, right? So we have these things, and hence this is false, right? And hence this is false, right? And hence this is false. Right? Everybody see that? So when I came up with the model, I kind of worked backwards, right? But when I wrote it up on a test, I kind of worked forwards, right? I got this from divine inspiration, right? On a piece of paper on my own, I'm working this out. Right? Does that make sense? All right. So now we have to prove this. We're going to prove the forward one, right? And what were my steps? Is, well, you first build the parse tree, right? So there's, I guess this could have been shifted over, but we have this side and then we have that side, right? And then that side parses like this, right? Everybody see how it parses? And in the one version of my slides, I then parse these things further, and this line then got parsed, and it was a big ugly tree, right? So now I'm thinking, well, let's just parse enough so we can get started and see if that's enough, right? So, right, so now we colored things based on, right? If she's assuring us, how do you color if she's assuring us? Well, it's yellow because she's assuring us, right? But here it's that the prover can give her an X, and then she'll prove this whole statement. Now you'll note I didn't go in and color this, right? That we assume this and we go to there. So I could have parsed this further and made, well, how does she assure us of this? Well, it's confusing how she assures of this and implies. So let's just not go there, right? All right, so then what do? Well, we want to prove it's valid. So we say, give me an arbitrary oracle. No, sorry, give me an arbitrary universe, right? So now we have our universe, and now here's the statement we need to parse, need to prove, all colored. And how do we do? Our first line, well, our first line was, let our universe be arbitrary, right? And then what's our next line is we have an oracle assuming the left side. And so then our goal is to prove the right side, right? How do we do that? We have an oracle assume the left side, and we have to prove the right side. All right, is everybody with me so far? We have two oracles. We have to prove something. All right. So then I can go in and say, I need to prove a Forall X. How do I prove a Forall X? I let my adversary give me an arbitrary X. Let's call it X sub Forall, right? And so here, there's I just plugged it in. There's a particular X that we need to prove it for, right? Everybody good? All right, now what is my goal is, I guess it was going off the screen, right? So I have to prove that this is true. And how do I do that? Well, I have two oracles, right? I have this oracle and I have this oracle. And both of these oracles is ready to take an object from me, right? So I have an object. So let's give my object to this first oracle. What does she do? She says something is true for all X, and hence it's true for the X in question, and hence we have this statement, right? Everybody follow that part, right? And then we go to our other oracle, and this other oracle is also ready to receive something. So I give it to her, and she says, well, I know it's true for all X, so it's true for your X, right? And now I have an oracle that knows this, and I have an oracle that knows this. So I know these two things, right? And if I try to parse the game further, it was giving me a lot of grief how to parse yellow implies. So, but we didn't parse it. We just have it. We have a yellow implies, and we have a yellow left, right? And so what do we do now? Yeah. No. Right? All right, so we know these two things, and what do we do now? We just do modus ponens, right? And we get exactly what we want, right? Everybody good with that? And then there's a formal game, which I haven't actually even completely checked. So we won't do that. Everybody good? All right, so what you're gonna have to do, right? You're gonna have to do one of these bang out from the purple table. You're gonna have to do an oracle adversary proof, right? And that, any questions about that? Yeah.
So for that, is it possible? Because like if beta finds X is true, then we can get alpha finds X three on three on.
Sorry, where? Oh, what are you doing? You want?
Would be like alpha is the alpha beta X is the arbitrary value. Sure that alpha actually finds.
All right. So let's go through it line. Do you get that the first thing that we need to do is the oracle assures us of this, and we have to prove all of this, right? And then if I have to prove all of this, you get that I have an oracle assures me of this, and I have to prove this. All right, so that's these three lines. All right, now how do you prove right? So we're trying to see how much if this was a test, how much can I do without thinking, right? And so I know I need this to be an arbitrary model, then I need to assume this, I have an oracle for this, I have an oracle for this, and I have to prove this. Right, so that's all just banging out by this parsing. All right, so now I need to prove a for all x. How do you prove a for all x? Arbitrary x, right? So I have an arbitrary x, and I need to prove that beta is true for it, right? So then I don't know how to do that, right? So I go up to my oracles, and my first oracle says something is true for every x. Well, that means she's waiting for me to give her an x, right? The only way I can use her statement, but I give her an x and she'll assure it. All right, so I was given an x. So it seems natural to give it to her, right? So what does she say? Here, here's one little trick that you guys have to figure out because I've never taught it to you, and you're going to have to figure it out on your own, right? I gave you these proofs by these guys in these bubbles, right? So you could write it up as guys in bubbles, or you could sort of say, Oracle says, I'm assuring you this. Oracle says, I'm assuring this. I need to prove, prover needs to prove this. Adversary gives me arbitrary value, right? Then I need to prove this, right? You can just write it, who's saying what as a proof, right? I wrote up a solution set, and that's what my solution set says. It says at this line, adversary gives me an arbitrary value. Oh, back to the prover. What do I need to the prover to do? Oh, prover now needs to prove this, right? Then what do I say? Oh, well, you could say, well, hey, the oracle is wanting a value, right? So I say, prover gives this value to the oracle, right? What does the oracle then say? The oracle then says, I know it's true for all x, so it's true for your x, right? Hence the oracle knows this, right? And what about the other oracle? The other oracle says, I know it's true for all x, so I knew it's true for your x, right? So do you see, now I know this about my x, and I know this about my x, right? So then I can do modus ponens, right? Everybody kind of follow that? And there are definitely examples out there where crazier parsing needs to happen, right? Maybe we need to parse this, but all our examples are going to be, you got stuff from the oracle, you got stuff you want to prove, and it's a straightforward game. Each of them has a straightforward game, right? And so you want to say, one thing you have to be able to say, if this is an oracle game, then you need to know the game, right? You need to know that if it's an oracle game, how does she assure you of a Forall? She assures you of a Forall by the blue prover gives it to her, right? Which is why I made it blue, right? And then once we give it to her, she needs to prove it. She needs not to prove it, she needs to assure it, right? So that's why this is blue, because the prover is giving it to her, and this is yellow because she's assuring it, right? Why did I color this the same way? Prover gives it for all, we assure, and she assures it. Why did I cover it like this? Because the whole thing is blue. The whole thing is blue. It needs to be proven by the prover. How does the prover prove a for all x? The adversary gives an x, and then he needs to prove it. He needs to prove the beta. This stuff is yellow because she's assuring it. This is being assured. This needs to be proved. Right? Does that make sense? So in some ways, this is the same as the split line, right? Remember, the split line is, these are the things that I know, and these are the things that I need. right? In fact, if we were to write the formal proof of this, that's how we would write it that way. We would write the oracle's assuring us this, so we know this, and we need this, and there's this split. This is what I know, this is what I need, right? So if you want to do it a little more formally, it would be fine too. You could do it by deduction, right? You could say, I know this and I know this. I assume them by deduction, and I need to prove this, right? It's the same idea. Everybody kind of getting this? Any questions people have for the test? So just let you know what my schedule is. These guys usually come at 12:30. So assuming they want to, or somebody wants to, I will be in my office at 12:30. If you want to talk to me between 11:30 and 12:30, you can do that too, but you would have to do it over lunch. Yes. I'm afraid there's quite a bit of it. Both. Yeah. Yeah. And so I will tell you there are 4. I'm making you do it 4 times. There'll be 4 English studies. Any other questions? Yep. All right, so so how would we play the game? Well, in some ways, where the first place we would kind of get stuck is we have an oracle assuring us of this, and we wouldn't know then how to use the oracle. If the oracle's assuring us of an implies, we haven't really covered, right? But then how do we prove this, right? We're trying to prove this, so we get an arbitrary X. So, right, so this is, and somehow I'm assuming that the oracle is giving me this. So the oracle here by proof, right? I'm not coloring it because I don't know how to parse this, but at least in pictures, I have the picture that if all this is true, then all this is true, right? And now I then say, well, I need to prove this. So how do I prove this? I say, adversary, give me an arbitrary X. And the adversary gives me 1. And in this case, the adversary gave me 0, right? Why? Well, why not? They're all about the same, right? And so now my goal is to prove that this gives me this, right? And how do I prove this gives me this? I assume the oracle assures me of this, right? So here I'm kind of thinking, hey, if I know this is true, can I get that this is true? Well, here from this assumption, I get that beta 0 is true, right? But where did that causality come from? Well, maybe it was alpha 1 being true that made beta 0 being true, right? Or maybe I need all of them to be true to get beta 0 to be true, right? But there's some sort of, I'm sort of stuck with from knowing alpha is true, I don't know how to get that beta is true for 0. Right? Does that make sense? I mean, this is where we're at. We know this is true. We need to prove that this is true. We have one oracle giving me this, and one oracle says, if everybody wants to play, then you get to play. You want to play. How do you convince people that you get to play? No, it doesn't work, right? So I suppose if I was going to parse this further, I would say, how does this useful? I would make this all right. So here, if this is yellow, A implies B, yellow, then how do I use this? Well, it's kind of as if this is blue, then I get that this is yellow. So we haven't done this parsing, right? But you can kind of say, how do I use this? Well, if somebody outside assures me that A is true, right? Then she will assure you that B is true, right? But I don't know that A is true, right? I mean, that's one way to prove it. There are other ways to prove it. Is I simply prove B without A, right? Another way to prove it is I prove that A is false, right? That's another way to do it. Oh, right? Yeah. Absolutely. Let me tell you what you should do on a proof, on a test. Right? Here I'm thinking it through. I'm thinking it through and on a paper on my own. And then what do I write on the test? Quite frankly, I would just write, this is what I would write on the test. I would write, maybe that's my universe, but maybe I've given you a picture, so you already kind of know that. And then I tell you, you tell me as much of the universe as I need, right? So you tell me those values, and then you can kind of argue, well, hence that's false, right? Hence that's false, hence that's true, right? Right, so that's false, so this is false, so the whole thing's false, right? In fact, I would say if you felt the need, you could put in a little more explanations in here, but more or less, I would say if you wrote this down, I would say great, right?